Okay, so in this video, we are looking at the divisor of a line segment. So this is a new formula in Leaving Cert higher level in coordinate geometry. So what this formula, or what we're essentially trying to do, is we are asked to find a point that's on a line, like so. So here's a line. We are asked to find a point, like such, that divides the line into like a certain ratio. Like say like 3 is to 1, where like this side is 3 times bigger than this side. Obviously that's not 3 to 1, but you get the point, right? So let's have a look here at this question. So here's the formula here. This is in your log tables. So it's a point PQ in the ratio A is to B, and where P is my point is x1, y1, and Q is x2, y2. So these are my two endpoints of my line segment, and I want to divide it in the ratio A is to B. So it's B times x1 plus A times x2 all over B plus A. That's my x coordinate. B times y1 plus A times y2 all over B plus A, and that is my y coordinate. So that's my x coordinate, this is my y coordinate. So let's have a look at this example here. So find the coordinates of the point which divide the line segment -1, 3 and 4, -2 in the ratio 2 is to 1. So A is going to be equal to 2, B is going to be equal to 1. So that's my ratio. Then let's fill out the points here. So B, so 1 times x1. So x1 here is -1. Plus A times x2, which is 4, all over B plus A, which is 1 plus 2. Then over here, B times y1. So 1 times y1, which is 3, plus A times y2, all over B plus A. And then if we simplify this down, I'm going to get -1 plus 8. So that's going to be -1 plus 8 is 7. So it's going to be 7 over 3 is my x coordinate. And my y coordinate is going to be 3 minus 4, which is -1. -1 all over 3. So it's going to be -1/3 is my y coordinate. So this point divides my line into the ratio 2 is to 1. So I have a line here. Say this is so I have a line here. So B is 4 minus 2. So say it's down here. A is up here. That's A. That's B. Whoop. I found a line here that divides in the ratio 2 is to 1. So it'll be something like this. 7 over 3 minus 1/3. So this length is going to be 2 times this length. The ratio 2 is to 1. Okay, so what about if we're finding a ratio when we're given the dividing point? So sometimes we could be given the dividing point and we're asked to find the ratio. So there's actually two ways of doing this. I'm going to show you both ways. So one way using our formula that's given, and another way is using the distance formula. So let's just use our formula first. So I have my points 4 minus 3 minus 2, 0 are the end point of a line segment, and the point 2 minus 2 divide the line segment internally in the ratio h to the k. Find the value of h and k. So h and k, so that's A, that's B. Sub it into my formula. So look up here, my formula is B, so k times x1, which is, so x1, y1, x2, y2. So k times 4 plus h times -3 all over h plus k. That's my x coordinate, and my y coordinate is going to be k times -3. So that's going to be -2 up here, my apologies. Right, so k times -3 plus h times 0 all over h plus k. So this is my dividing point now, and I know my dividing point is 2 minus 2. So with this, right, I'm actually not going to get a value for h and k. I'm actually just going to get like a ratio of sorts. So we only really need one coordinate for this, and you're going to see why now in a second. So I'm going to choose my y coordinate here. So my y coordinate is going to be minus 3k all over in h times 0, 0, all over h plus k. That is equal to minus 2. Multiply across by h plus k, so I have minus 3k is equal to minus 2h minus 2k. I want to bring k's and h's over to one side. So I'm going to bring my k's to the right and my h's to the left. So I have 2h is equal to minus 2k plus 3k, which is just k. So I have now 2h is equal to k. So how can I get my ratio from this? So what we just need to recognize here, whatever value of h is, k is going to be double it. So when h is equal to 1, k will be equal to 2, right? So 2 times 1 is 2. So k is 2 when h is 1. So what do we notice here? Well, the ratio is going to be, so h is to k, 1 is to 2. That is my ratio there, because my k value will always be twice my h value. So then the other way of doing it. So the other way of doing it is using our distance formula. So there's A, ding, this is point C, bing, and this is point B. So I roughly sketched this, right? This is actually not correct, but oopsies, whatever, we'll deal with it, right? And this is minus 2, 0. So what I'm going to do is I'm going to find the distance AC, and I'm going to find the distance CB, and then I'm going to put them in ratio to each other like so, and I should get the same ratio. So let's try it out here. So if we want to be more accurate here, I suppose, no, that's fine. Right, so let's try it out. So my distance formula, AC, that is going to be equal to square root of, so 4 minus 2 squared plus minus 3 minus negative 2 squared. That is going to be 2 squared plus minus 3 plus 2, which is minus 1, so minus 1 squared. 4 plus 1, which is root 5. So the AC is equal to root 5. Right, let's try CB. CB now, so I'm going to have 2 minus negative 2 squared plus minus 2 minus 0 squared. So I'm going to have here, so 2 minus negative 2, that's going to become a plus 2. So it's 2 plus 2, which is 4. So I have 4 squared plus minus 2 squared. That is 16 plus 4. And I'm going to get root 20. And if you put root 20 in your calculator, that can split up into root 4 times root 5, which is equal to 2 root 5. So I have my two distances here. So if we go back up to my ratio here, AC is equal to root 5. CB is equal to 2 root 5. So I need to simplify this ratio. Divide both sides by root 5. And you get 1 is to 2 as your ratio. So I've proven the same thing using two different ways. So, and then the last way, right, we could be asked these dividing a line segments would be via a translation. So we've come across translations already with area of a triangle. So what do we mean by dividing a line segment by translation? So recall or learn very quickly that translating a point means to move it. So it just means we're shifting it up or down or left or right, etc., etc. So to translate a point, we apply one translation to the x coordinate and another translation to the y coordinate. So if we are given the ratio into which the line segments is to be divided, we can apply this ratio to the translation to find the coordinates of a dividing point. So if we say AB is to be divided 3:2, then the dividing point should be 3/5 of the way from A to B. So let's have a look at this question here and see what I mean. So if A is equal to 3/5 and B is 7/2, our end point of a line segment, find the point that divides the line segment into the ratio 3:2. We are tasked with dividing the line segment AB into the ratio 3:2. So we aim to find a point D that does this. So a point D is going to be 3/5 of the way between A and B. So we can use the ratio to determine the translation that maps A to B. So what we need to do is we need to kind of draw a sketch of my translation now again. And what's happening here? Well, there is there's a point C. Sorry, I said D, but whatever. It's a dividing point. It doesn't matter. So 3/5. I multiply my translation by 3/5. So 3/5 times 4 is going to be 2.4. And 3/5 times minus 3 is going to be minus 1.8. And then what I do is I now apply this new translation to the 0.35. So I add 2,4 and subtract 1.2. And my new point is 5.4, 3.8. That is that's my dividing point there. That is using translation. So let's look at one more example of using translation. This time we are given my dividing point, but we're not given my end point. So A equals A is 2 minus 3, B is xy, are 2 points in the plane. The point 5,3 divides AB in the ratio 3:2. Find the values of x and y by translation. So again, I'm in the ratio 3:2. Therefore 3:2, therefore A to C takes up 3/5 of my journey, and C to B takes up 2/5 of my journey. So if 3/5 of my translation is, so let's look at the translation here, 2 to 5, well that's plus 3, minus 3 to 3 is plus 6. So 3/5 of my translation is 3/6. Plus 3 plus 6. What is my whole then translation, or my whole kind of journey, my whole translation? So what we do is divide both sides by 3. So I get 1/5 is equal to 1, 2. Multiply both sides by 5. I'm going to get 1 is equal to 1 times 5, which is 5. 2 times 5, which is 10. So actually, my whole translation from A to B going to be plus 5 plus 10. So my starting point is 2 minus 3. And my ending point would be 2 plus 5, which is 7. And then minus 3 plus 10, which is 7. So my end point here is going to be 7, 7. Right, so let's look at some exam questiones now. So the points, so this is from the 2022 paper. So the points A8 minus 4, B minus 1, 3 are end points of the line segment AB. Find the coordinates of point C, which divide AB internally in the ratio 4:1. So again, use my formula. BX1 plus AX2 all over B plus A. And then BY1 plus AY2 all over B plus A. So X1, Y1, X2, Y2 in the ratio 4:1, so A, B. So my ratio is going to be 1 times 8 plus 4 times minus 1 all over A plus B, which is 5. And my y coordinate is going to be 1 times minus 4 plus 4 times 3 all over 5. Sorry, hope you can see it there. So my point C is going to be 8 minus 4, which is 4 over 5. And then minus 4 plus 12 is 8. And that's going to be 8 over 5. So my coordinates now of that divide this into the ratio 4:1 is 4/5 and 8/5. So let's look at another one. So this is 2011. So again, exact same thing. P and Q are points minus 1, 4, minus 1, 4, and 3, 7 respectively. Find the coordinates of the points that divides PQ internally in the ratio 3:1. So again, use my formula. BX1 plus AX2 all over B plus A. BY1 plus AY2 all over B plus A. And that is going to be, so that's A, that's B, X1, Y1, X2, Y2. So that is going to be 1 times minus 1 plus A times 3 all over B plus A, so 3 plus 1 is 4. Then my Y coordinate is going to be 1 times 4 plus 3 times 7 all over B plus A, which is 4. So minus 1 plus 9 is 8. So 8 over 4. And then 4 plus 21, since I can't already see that, that's plus 3 times 7. So that's 4 plus 21, which is 25 over 4. And then this simplifies down to 2. And 25 over 4, I don't think that does not simplify down anymore, so we leave it as is. So 4 plus 3 times, let me just double check my sums. Yeah, that's it there. Right. Then final question here, it's an exam style question. So the points A, minus 5, 3, B, 3, minus 1 are endpoints of a line segment. The point 1, 0 divides the line segment into ratio h to k. Find the value of h and find the value of k. So what we're going to do is use my formula. So that's going to be x1, y1, x2, y2, a, b. So I have k times minus 5 plus h times 3 all over a plus b. That's my x coordinate. Oh, sorry, not a plus b, so h plus k. Then I have here 3 k times 3 plus h times minus 1 all over k plus h. And that is equal to my dividing point 1, 0. So again, I only really need to choose one point here. So I'm going to choose my y coordinate because this is 0. So this is going to make cross multiplying very easy. So I have 3k minus h all over h plus k is equal to 0. Multiply both sides by h plus k. I'm just going to get 3k minus h equals 0. 3k is equal to h. So I'm finding, so h is equal to 3k. So if I notice here, right, when like k is equal to 1, h will equal to 3. So the ratio is going to be 3:1. So the ratio for this is going to be 3:1. And again, remember the other way you could do it is we can use the distance formula. So I have a minus 5, 3. I have b up here. So a, b, bing, and I have the point c, which is like here or something. C, which is 1, 0. So I'm going to find the distance AC, find the distance CB, find the ratio between them, and hopefully we should see it's 3:1. And then B is equal to 3 minus 1. Right, so AC is equal to square root of So minus 5 minus 1 squared plus 3 minus 0 squared, which is going to be minus 6 squared plus 3 squared. 36 plus 9, which is 45. Then square root of 45, that's simplified down. That simplifies down to 3 root 5. Right, let's find CB. So from the divisor point to B, so my distance is going to be, so it's going to be 1 minus 3 squared plus 0 minus negative 1 squared minus 2 squared plus 1 squared. CB is going to be equal to 4 plus 1. CB is equal to root 5. So put these in ratio to each other. AC is to CB. I'm going to get 3 root 5 is to root 5. And therefore divide both sides by root 5. And I'm going to get the ratio 3 is to 1. And there we have it. There's 2 different ways of doing that question. Right, and that is the divisor of a line segment. I hope this video was some help to you guys, and I'll catch you guys later. Bye.